Hello students, now let us try to understand our fifth unit, that is synchronous machines. Okay, so this class is introduction to our synchronous machines. Okay, we have so far covered our single phase and three phase induction motors. Now we are going to understand synchronous machines. Okay, so what is a synchronous machine here? Synchronous machine is a doubly excited AC machine. Okay, we have so far covered doubly fed induction generator. So just like that, we have synchronous machine as doubly excited AC machine. Okay, so its field winding is energized with DC source. This is one excitation, and its armature winding is connected to a AC source. That's why these two are called double excitation. Okay, we have double excitation. That's why it is called doubly excited. Okay, our three phase induction motor is a singly excited machine because we supply only three phase AC supply to stator. There is no supply to rotor. But here in synchronous machines, we are going to supply a DC source to field winding which is connected to rotor. Okay, and armature is in stator generally, and it is connected to a AC source. Okay, while it is operating as a motor, our synchronous machine takes active power from the AC source. Here our synchronous power takes active power from the AC source connected to armature winding, and while generating operation, our synchronous machine generates or delivers or exports AC power. Okay, while it is operating as a motor, it takes active power. We already know that, we have seen in three phase induction motors, right? Okay, when it is operating as a motor, it takes active power in. While it is operating as a generator, it delivers or exports our AC power. Okay, this is generating and operating mode of our synchronous machine. While these two operations, our field winding of synchronous machine always absorbs or takes in power from DC source. While it is operating as a motor or while it is operating as a generator, field winding of our synchronous machine always takes in power from a DC source. It always takes in, it always connected to a DC source. Okay, the field winding of our synchronous machine is always connected to a DC source while it is operating as a motor or it is operating as a generator. Okay, so that is the idea. So it always takes in the DC power from the field winding. Okay, so since our synchronous motor delivers AC power, it is also called as alternator. Okay, the name of the synchronous generator, we call it as alternator. Synchronous generator, this short form for synchronous generator, is also called as alternator. Okay, that is the idea. And under steady state condition, the speed of our synchronous machine is synchronous speed. It is ns here. Okay, you have already gone through what is the synchronous speed is 120 f by p. F is frequency of armature currents and p is number of field poles. Okay, in our induction machines, we have a term called slip because it has a slip speed. There is a difference between synchronous speed and rotor speed, but in our synchronous machines, there is only one speed, that is synchronous speed. The rotor of the machine will operate at synchronous speed. Okay, there will be no term called slip in synchronous machine here. Okay, the speed of the machine is synchronous machine. Okay, this is about introduction to synchronous machines. So this is a doubly excited AC machine. Its field winding is connected to DC source and armature winding is connected to AC source, and while it is operating as a motor, it takes active power from the AC source. While it is operating as a generator, it delivers or exports our AC power. Okay, and it always takes, the field winding of our synchronous machine always takes in DC source. Okay, DC power, and as it is delivering AC power, it is called alternator. The speed is 120 f by p. Okay, so the most of the generators we are using in industries. Okay, so a synchronous generator is universally employed for generation of three phase power in all electrical generating stations. Okay, our electrical generating stations use synchronous machine as a generator. Okay, and it is a large sized machine in electrical machine which is having a rating of 1700 megawatts. Okay, this is very large sized machine. In all our electrical machines, synchronous machines are the largest sized machines having the rating of 1700 megawatts so far. Okay, this is mentioned in the literature. Okay, our generating stations use synchronous machines as generators to generate the power that we consume at our homes or industries. Okay, all thermal and hydroelectric power plants use synchronous generators. Okay, we will try to discuss what are the types of synchronous generators in the next class. Okay, so this is about introduction to our synchronous machines. Okay, in the next class we will be discussing constructional features of our synchronous machines. Okay, thank you.